Yes, so now we are going to talk about how to work with keil microvision software. So this is the step-by-step process how to create your project and how to compile a general embedded C program by using keil microvision. So okay, just double click on your installed software from your PC or desktop. So this is the default project file, it will open. So just try to close this default project which is opened with your microvision software. Now this is the first program or first project you are going to create by using keil microvision. For this, select project tab and choose the option new project, and here you have to choose a specific folder from a specific drive. Now I am going to choose a local disk from my computer, and here I am going to create a specific folder embedded C programs. So this is my folder name, and just open your folder and give your project name. This is the sample project. So this is your project name and click on save option. So this is the window for choose the microcontroller from a different manufacturers. This is the list of all microcontroller manufacturers. From this, choose your microcontroller manufacturer, either Philips or Atmel or Samsung or Motorola or any device from a specific manufacturer. Now I am going to choose a microcontroller manufacturer Atmel, so which are arranged in alphabet. So just click on plus mark of the manufacturer name left side, and this is the list of all devices from this manufacturer. From this, choose your microcontroller if you want to work with any specific device. Choose your microcontroller and click on OK. And this is the startup code warning. This startup code have all the default values of your registers and memory locations, and click on no. So now you people selected the device from a specific manufacturer, and you are going to write program for a specific target device which is 8089C51. Now, so for writing your program you have to open editor. So this editor is what this which is used to write the program. And how to open editor window, go file tab and choose new. This is the text editor which is used to write the program. And now I am writing a simple program for operating IO ports high to low. This is hash include reg51.h. This is the header file name for all 51 family controllers, and I am taking void as a return type for your main function, and this is the open bracket. Now the program starts from here. Now I am using the controller port name P1, which is 0x00. Just I am assigning logic 0x00 stands for I am assigning logic zeros for all IO pins. And for operating with some time delay, I am taking a integer variable with a self for loop. So now I am taking an infinite loop for performing my IO ports continuously. This is while of 1. So now I am making all IO pins as logic 1s by assigning hexadecimal value 0xFF, and I am taking self for loop for I equals to 0, I less than 60,000, I plus plus. So I less than 60,000 and increment I value and terminates your for loop with semicolon. This semicolon means we are incrementing I value up to 60,000, so this for loop it's keep on executing, and then I am assigning port value logics as 0x00. This is for all IO logics, IO pins logics as zeros. The same for loop you can apply for repeating your delay. So this is the just approximation time delay value you are giving for operating your IO logics. Okay, so after writing your complete program, just save your program, because you people have to know about the complete development cycle, which starts with editor, and now we are looking for compilation. For compile your program, just go file, save this program first of all. Now this is a sample program. Now I am writing IO port and which language used to write this program. Now I used embedded C language, so you have to save this program with .c extension. Suppose you people wrote the program in assembly language, try to save with .asm. So click on save. So if it is, so your file name doesn't allow any special characters. Okay, so just click on save. So now your program is saved. And for compilation for this program, you have to add this C source file to the target device. So because on which target device you want to run this program, you have to add to this source group. So there is a project workspace window on the left side of your editor window. Choose this target one and click on this, and you will get source group 1. Just right click on the source group 1, you will get the options add files to source group 1. Now which C program you want to compile, just choose that file and click on add and close. So once your file is added, you will get plus mark for this source group 1. Now so this program is going to run on your specific target device. For observing your errors and warnings of your program, so go project tab and select the option build target. Otherwise press F7 from your keyboard. Now so this compiler window which will shows the errors and warnings of your program. Now I don't have any errors and warnings, 0 errors and 0 warnings of my program. So this is the compilation is over. Now if you want to debug this program, then you have to choose this debug tab and select the option start or stop debug session. And this is the keil microvision software which is supporting your code size execution up to 2k byte size. Now click on OK. So if you want to see the response of your IO pins, whether they're changing their logics, logic 1 and logic 0 continuously, go peripheral tab and open your IO ports, and from this choose the which IO port used in the program. So now this is port 1 which is used in our program. So just see the response of your port pins by running this program. So if you want to run the program, again go for debug tab and click on run. Otherwise F7 from your keyboard. This is the response from your IO pins for your embedded C program. So this is all step-by-step execution and compilation and debugging of your simple embedded C program. This is the way you people have to know step-by-step process for operating your keil microvision IDE tool. If you want to stop this debugging, then go for again debug tab and stop running. And if you want to stop this debug session, again go for debug tab and use the same option for start or stop. Now so you people written the program on editor and you compiled and you checked the Yes. So creating hex file and linking with checking with hardware simulation tool. Okay, so this is the program and which is toggling your IO pins and creating hex file. How to create hex file? Just select your target and just right click on this and choose the options for target 1, and this is the oscillator frequency which is supported by microcontroller families. 8051 supports the oscillator frequency from 4 megahertz to 40 megahertz, which is now I am giving a specific frequency 11.0592 megahertz, and just highlight the option use on chip ROM and click on output and choose the option create hex file and okay. So before we are going to build, just there is no hex file path here. Now just go project tab and click on build target. It will show hex file path. Now this is the hex file name for your complete project. Now if you want to test this program with hardware result, there is a tool for us which is proteus schematic capture design tool, which is used to run for all microcontroller hex files. So from this, just click on this P, which is help us to choose the devices from the library 8089C51, and I want to test the LED's status, IO pin status with the help of LEDs, logic 1 and logic 0 status. So just choose the device and connect your LEDs with port 1. Why? Because I used port 1 in the hardware. Yes, connect your all anode ends of LEDs with IO pins and make sure all cathode ends are ground, and you people can choose this ground connection from terminals mode and choose the ground and connect your all LEDs cathodes with the ground line. After giving your all hardware connections, just double click on controller. It will ask for hex file path, and this is your program file, and click on this folder symbol. It will ask for program file, so which is created in embedded C program folder. This is my hex file name. You can find out from Keil software what's your hex file name. Just choose your hex file path and click on open and give the same oscillator frequency, which is as 11.0592, and click on OK, and you can play this hardware design. It will affect your IO pins logics as high and low. So this is the way you people can check your hardware results with the help of Keil software by using proteus combination. So this keil and proteus combination which help us to design so many applications in the embedded system, which is you can develop your software